Hey guys, welcome to Chaos Theory. My name is Nicholas Burial, and in this video we're going to be showcasing a bit of materials, or making materials for this Sonos Play 1 speaker. But first I want to address the little diode we were trying to make in the last part, which didn't really go too well. So let's just go ahead and do that first. So I'll create that by creating a box and then just editing the box to our needs. So I'm gonna reset its position to 0 on X and Y and then move it down. Mostly because we already put our speaker in the center of all axes, so it's way easier for us to place it exactly in the middle. Just do a ring select around this edge and chamfer it. Chamfer the edges just a little bit to something like maybe this. Get this polygon up here, hold down Control and go to edge. That'll convert your selection to edges, and then we can chamfer this selection as well, just by maybe something like this. And if we want, we can extrude this in a little bit and collapse it so it ends nicely like the top of a cylinder. Delete the bottom face because we don't need that. Now we can just move it down here to something like this maybe. We can attach it to our speaker, so it's part of the same object. Go to Turbo Smooth, double check that we're happy with the results. Maybe move it around a little bit. We can go to Show End Result to get a better idea of how it looks or not. Something like that. We might move the buttons a little bit further down now that I look at it, and quite happy with that. So first off, there's a few things I wanted to address. When we're going to be making materials for this, we want to open up our slate material editor. I'm saying this specifically as the slate material editor because I've seen quite a few tutorials out there using the compact material editor. So if you hold down, if you press M, you get up your material editor. But if you hold down this button, which is the button for the material editor, you can hold it down and go to the compact editor instead, and you will get this look. I've seen quite a few tutorials been made also recently where they use this material editor, which is, it's fine. It's the old material editor for 3ds Max. And it doesn't take up as much space, but it's a lot more confusing when you get into the nitty-gritty part of your materials. So I would really recommend you getting used to using the slate editor instead if you're not already. So first thing we're gonna do is we need to activate V-Ray as our renderer. For this project I'll be using V-Ray CPU and not GPU version, so just V-Ray 5 in this instance. We don't need to look at render settings or anything yet because we're just doing materials. And we can right click here, go into materials, go into V-Ray and find the V-Ray MTL or V-Ray material, which is the default standard material we're going to be using to make pretty much 90% of all materials we ever need to do. So from here we can assign our materials to selection through this button up here, or we can drag from the output node of the material itself and straight over to the object, and it'll apply it to the selection we have. The selection can either be mesh, as it is right now, or it could be polygons as well. So if we were to make something different for the buttons, for example, if they needed a different material, which, they do at some point because we're going to be making some textures as well, we can hold down Shift, copy the material so we don't need to go into all of that again, give it a different color in the diffuse. I'll explain this in a sec. And if I drag from the output node now straight onto my selection, it'll actually assign that material to only the selected polygons. In this instance I used elements. We could also, if I undo this, go back to these two buttons and assign the material to selection from here, and it'll do the exact same thing. Now what actually happens is that 3ds Max when you apply a material to them, it sets an ID for the polygons. And as soon as I select some different polygons and I assign it to those polygons, it'll set a new ID, so ID 2 in this instance. And it'll keep doing this for us. And then it actually replaces the material. So these two materials specifically are used, but they're not the ones on the object itself. The object itself, as in the speaker, has this multi-sub material on it now. So if we go to see materials over here on the left side, you can see a multi-sub material has been generated, and it has multiple IDs. In this instance, it has 2, and it has assigned one material to material ID slot 1 and the other material to ID slot 2. So that's how it knows which material to use. So if I just applied, if I made a new material, let's just make it a crazy color here. If I assigned this material to the whole speaker, I can actually reassign this material, multi-sub material, to the speaker as well, and it'll still remember the different IDs. It doesn't override the IDs when you assign a material to the object itself, but it'll keep those IDs. If, however, we assigned it to all polygons, so if I select all polygons and assign this material to that, it'll call all of them material ID 3 and actually make a new multi-sub material because it already started that. So this new one has 3 IDs and they are all assigned ID 3 on that in this instance. So it gets a little bit confusing, but without worrying too much about which material ID is which, you know, just roll with it. In this instance, I'll just reset my IDs to 1 and assign this material to ID 1, so I don't have any multi-sub materials over here. And we can start thinking about how to create our actual materials. Now, I do want to address one thing before going into these materials. There was a comment on, I think, the last video about why I wouldn't make, or why I didn't choose to make the holes for the buttons, and I haven't done so. I just, you know, intersected the buttons straight through the mesh, which is, you know, in this case I deemed it fine. For sure, we could make the holes in the mesh first and then create a button around those holes to get that nice little lip around. But, you know, for most cases, unless we're doing like a really close-up visualization of the product, which we are kind of doing in this tutorial, I suppose. But I'm not gonna end up just using this you know, this object on its own in the future. I'll probably include it in a interior visualization and use it for all different kinds of things. And I'm not really gonna get this close to the object all the time, so it's not really necessary to do all these details for an object like this. And also, this is a beginner tutorial, so, you know, my idea would be to actually, you know, try and keep it a little bit more simple, so we're not going to spend, you know, a whole episode just thinking about how to create these holes down here. If you want to learn more about, you know, modeling, go, like I said in the last video, go to someone else's channel like Arimus 3D. He has a lot of great tips on how to make different kinds of, you know, how to solve different kind of problems with meshes and so on. So, all right. Before we're in the next video, we'll be covering all the different materials we're going to be making for this object. But to begin with here, just so we get started, we could talk a little bit about the different materials, or the material itself and its properties. So what we need to know is that we have different sections on our material itself. We have a diffuse section, reflect, and refract. Those are the ones that we're going to be focusing on the most. We'll also be looking a little bit about the self-illumination for the actual diode we have over here. So we have the option to turn it on or off if we want to. the diffuse section, or the diffuse color of a given object, is the object's color. This is also referred to as an albedo or base color, depending on what system you're on. So in 3ds Max and V-Ray, we call it a diffuse. If you were using Unreal Engine or something like that, maybe on Unity, as far as I remember, they call it base color. And sometimes you will also see a albedo color instead. It's all pretty much the same. It's still the color of the object, but they do refer to what's expected in a map if we use the map with the diffuse color instead of just a solid color like we are right now. But overall, it's pretty much the same. Reflect is the reflectivity of the object itself. So how reflective the object becomes. So if we look here in our material slate, it is a preview. We can see that it becomes, reflective, so it looks like plastic. Glossiness can also be referred to as roughness, not to be confused with this roughness up here. The roughness up here is the micro surface roughness, like dust or very small, it dulls the colors basically. But the glossiness is, and roughness for glossiness, is more referred to when you're working with a PBR material, which this is in this instance. PBR is a physical-based rendering material, which is a standard across almost all rendering platforms now. So if you make a surface painter or if you got substance painter materials or something like that, they will all be probably PBR materials, and you can use them in whatever engine and get the same results every time. So in this instance, we're using glossiness, but if you're using roughness instead, it'll be the exact opposite of glossiness. So glossiness of 1 is sharp reflections, and glossiness of 0 or below 1 is getting more and more blurry reflections, basically. It's the same amount of reflections, but they will be blurred out and spread out a lot more. If it was roughness instead, which we can use in V-Ray as well, we can go to the BRDF rollout and select use roughness. It'll be the exact opposite. So a roughness of 1 is as rough as it gets and as blurry as it gets. If it's a roughness of 0, it's the exact same thing as glossiness as 1. So whatever map we have, if we get the map from somewhere else and it's called a roughness map, it's supposed to be used in this channel. But if we don't want to change it to roughness and we use glossiness, we can just invert the colors from off black and white to, just invert them, and you have the exact same result. Other than that, we need to tell the material if it's a metal or not. These can be half values as well, or lesser values. But in theory, you should always keep these at either 0 or 1. Because a material cannot be a little bit metal. It'll always be either metal or not. So that's the easiest way of remembering how to deal with metalness. Is just ask yourself the question, is the material I'm trying to create a metal, yes or no? If it's a metal and it's painted, the answer is no, because you're not looking at metal, you're looking at paint. So, keep that in mind. Then we have refract, which is the refractivity of an object. So if it's refractive, it'll become something like glass, so non-opaque materials. So glass, water, gemstones, all kind of things like that. We're not really gonna do anything with refract in this series, but it's nice to know. And then we have self-illumination, which kind of is self-explanatory. This is also called an emissive map in some engines. Self-illumination makes the material itself illuminate as if it was a light source, but it won't emit light per default. For that, we need to put on this GI tab. However, you might get issues with noise and all crazy things when you use the GI to calculate the light from it instead. So there's quite a few different ways to get around that problem that we might be able to look at some point. So anyway, that's the very, very short and fast way to explain what the default materials consist of. Keep along and watch out for the next video where we will be actually making some materials, and yeah, that's it. I will see you later. Bye.